Welcome to this training video focusing on Snowflake Cortex search. We will explore how this powerful feature uses advanced AI capabilities to unlock high-quality semantic search across your data platform. Let's get started. Cortex search is a powerful and essential core feature that resides deep within Snowflake's comprehensive suite of artificial intelligence and machine learning services, providing users with cutting-edge tools to analyze data. The primary function of this innovative service is meticulously crafted to deliver high-quality semantic search capabilities, fundamentally transforming how you interact with and retrieve valuable insights from the vast amounts of data housed in your Snowflake environment. Unlike outdated traditional search methods that rely heavily on literal keyword matching, semantic search uses advanced natural language processing to intelligently comprehend and execute searches based on the true meaning and contextual relevance of the input query, leading to significantly more accurate and useful results. Because of its unique ability to understand meaning, this efficient service acts as a crucial foundational component, making it indispensable for constructing robust retrieval-augmented generation, or RAG, architectures, which enhance the responses of large language models by giving them relevant, external context to draw upon. To set up and effectively manage this intelligent feature within your cloud environment, you must use the specific dedicated structured query language command, Create Cortex Search Service, which orchestrates the necessary underlying data structures and compute resources. Successfully deploying and utilizing Cortex Search also necessitates meeting certain prerequisites, which include obtaining the correct and sufficient privileges required to create and configure the necessary supporting database objects, such as databases, schemas, and virtual warehouse objects dedicated to the seamless execution of these sophisticated AI features. This diagram illustrates the high-level functional flow of Cortex Search within the Snowflake architecture. We begin on the far left with your existing data in Snowflake, representing the comprehensive source of information that will be indexed and searched by the AI services. This data is intelligently passed into the Cortex AI layer, which manages the various AI capabilities available to users within Snowflake's platform, ensuring security and scale for all operations. The formidable core strength that underpins the efficiency of semantic search within Snowflake Cortex is derived from its capability to transcend simple textual comparisons, converting complex documents into abstract, precise numerical representations. These essential numerical representations, universally referred to as vector embeddings, are ingeniously engineered to meticulously capture the nuanced meaning and inherent semantic value contained within the original text, thereby enabling the intelligent search system to accurately decipher the subtle, contextual relationships existing among various words, specialized terms, and complex phrases. Visualizing this concept, when mapped within a sophisticated, high-dimensional space, a hallmark of modern machine learning techniques, the vectors derived from pieces of text that share fundamentally similar meanings inherently gravitate toward each other, effectively clustering and aligning to point consistently in the same approximate general direction, illustrating their semantic likeness immediately. Cortex Search harnesses this mathematical property by swiftly and accurately calculating the geometrical distance, typically referred to as vector cosine similarity, between the processed numerical vector of the user's input query and the stored numerical vectors of all indexed documents, thereby retrieving the most contextually relevant results efficiently, regardless of whether the exact keywords were used originally in the indexed materials. Furthermore, to optimize indexing quality and search precision during the initial service setup process, large original documents are first meticulously segmented, or intelligently chunked, into optimally sized, smaller sections. This critical step ensures that each index entry maintains rich context, maximizing search fidelity. This advanced vector-based methodology represents a paradigm shift in data retrieval, significantly enhancing the precision and overall accuracy for handling even the most complex and nuanced search tasks, such as cross-referencing detailed technical manuals or analyzing previously resolved help desk tickets effectively. This sequence diagram illustrates the detailed flow necessary to achieve semantic search functionality using vector embeddings. To successfully initiate and fully establish a Cortex search service within your environment, the essential first step involves executing the dedicated structured query language command, Create Cortex search service, which must clearly specify the definitive underlying source of the data you wish to make searchable, typically pointing to an existing table or a materialized view that holds the textual content. During this critical initial definition phase of the service creation process, you are required to meticulously identify and accurately select which specific columns within your chosen data source contain the textual content that needs to be systematically indexed and subsequently made available for robust, efficient semantic searching operations by the underlying system. The subsequent comprehensive indexing phase is handled entirely by the service itself, which autonomously and expertly manages the complex workflow of automatically chunking the raw source text into optimally sized segments, efficiently generating the precise vector embeddings necessary for semantic comparison, and seamlessly building the specialized high-performance search index infrastructure that guarantees rapid query responsiveness. For users who prefer a streamlined, guided experience, this entire setup and definition process can be easily and conveniently accomplished by utilizing the intuitive creation wizard available directly within the Snowsite user interface, offering step-by-step assistance through every required configuration decision. Conversely, for seasoned developers or scenarios demanding precise control over resource allocation and fine-grained parameters for programmatic setup, the service definition can be thoroughly created and deployed entirely through explicit undetailed SQL statements. Furthermore, as part of optimizing performance for the indexing task, it is highly recommended practice to carefully review the complete list of available embedding models offered and select the specific one that is most appropriate for your particular data set, such as choosing a model prioritized for sheer indexing speed or one that offers broad multilingual support, ensuring optimal results. To execute effective searches against your newly configured Cortex search service, all querying operations must be initiated by invoking the specialized Snowflake structured query language function, designated precisely as snowflake.cortex.search_preview, which is engineered specifically for interacting with the semantic index and retrieving highly relevant contextual information. Successful invocation of this particular function mandates the explicit naming of the fully qualified Cortex search service instance being queried, alongside the provision of an essential, mandatory JSON object. This object serves as the container for all specified search parameters and configurational inputs needed for execution. The two fundamental and absolutely crucial input parameters required within this JSON object structure are the actual query text, which represents the user's natural language search term for semantic analysis, and a carefully prepared array listing the desired output columns, which dictates exactly what data fields should be extracted and returned from the matching index documents. To achieve highly targeted and specifically narrowed down results, users have the capability to optionally include conditional constraints by thoughtfully utilizing the comprehensive filter parameter, allowing for dynamic filtering such as restricting the search results exclusively to a particular geographical region or filtering based upon a defined list of user_emails. Furthermore, managing the scale and ensuring resource efficiency of the return dataset is achieved by leveraging the versatile limit parameter, which effectively dictates the maximum allowable number of result entries to be returned, noting that this critical parameter defaults intelligently to 10 results but can be expanded considerably to a maximum threshold of 1000 results if required. Given the intrinsic design of the function, which inherently outputs a comprehensive JSON object encapsulating the entire search response, the most common and practical final step in the complete SQL statement involves systematically using the parse_JSON function to seamlessly extract only the actual results array, making the output immediately consumable and highly usable for downstream tasks. Cortex Search provides a necessary and foundational capability that is strategically essential for constructing effective and accurate retrieval-augmented generation, universally abbreviated as RAG, architecture specifically within the robust and governed environment of Snowflake. Within the highly defined sequence of a RAG workflow, the initial natural language input submitted by the user immediately triggers a sophisticated and high-performance semantic search operation. This search relies heavily on Cortex Search's indexing capabilities to efficiently retrieve only the most relevant contextual data snippets or document chunks from the governed source material. This carefully retrieved contextual data, which functions as the authoritative external knowledge base, is then systematically aggregated and passed directly as supplementary information, alongside the original query text, to a designated large language model function, typically utilizing the powerful Snowflake.Cortex.complete function for subsequent synthesis. By having access to this highly specific and contextually relevant information retrieved from your proprietary internal data, the large language model is uniquely positioned to generate an extremely informed, precise, and reliable answer, significantly mitigating the common risk of factual inaccuracies, otherwise known as hallucination, inherent in using general-purpose LLMs. Significantly, beyond internal operational use, Cortex search services possess the inherent ability to be formally published as specialized data products known as Cortex Knowledge Extensions, abbreviated as CKEs, establishing a mechanism for secure and highly governed sharing of indexed data assets across organizational boundaries. These valuable CKEs authorize data providers to securely expose proprietary or officially licensed indexed content for monetization or distribution through mechanisms such as the centralized Snowflake marketplace or via secure private listings, enabling end consumers to seamlessly integrate this external, specialized knowledge into their customized Cortex AI applications. This diagram clearly maps out the essential components and directional data flow within a retrieval-augmented generation, or RAG, pipeline, emphasizing the central role played by Cortex Search. The workflow starts with the user query, representing the initial request submitted by the end user seeking specific information or requiring detailed synthesis. Cortex Search, at its foundational and mathematical core, operates entirely dependent on specialized, highly optimized embedding models. These models, often categorized under the high-performance Arctic Embed family developed by Snowflake, are meticulously engineered to accurately and reliably execute the complex conversion of raw text data into the required high-dimensional numerical vectors. Making an informed and judicious model selection is critically important because the specific choice inherently dictates numerous essential operational characteristics, including the specific number of output dimensions for the vectors, the measurable time required for comprehensive indexing procedures, and crucially, the level and type of language support the resulting search service will effectively possess. For instances where your organizational datasets are strictly limited to text containing only the English language, the highly efficient Snowflake Arctic Embed MV1.5 is enthusiastically recommended as the superior choice, as it is engineered to generate a manageable 768 dimensions while concurrently achieving the absolute fastest available indexing times across the entire model catalog. Conversely, in scenarios where your foundational source data comprehensively encompasses a broad spectrum of multiple international languages, the significantly more versatile Snowflake Arctic Embed LV2.0 model demonstrably presents itself as the highly suitable and strategically optimal choice for ensuring accurate semantic representation across all language types. This larger, more capable L model is specifically built to robustly support expansive multilingual datasets with exceptional efficacy, consistently generating a higher count of 1024 dimensions and consistently delivering high-quality performance metrics across both English-centric data and all non-English textual datasets it encounters. It is paramount to note that the explicit definition and selection of the preferred embedding model is a critical configuration step that must occur during the initial creation of the Cortex search service itself, thereby guaranteeing that the high-performance vector index is systematically built utilizing the precisely correct, optimized vectorization technique tailored to the specific characteristics and language content of your source data effectively and immediately.